Welcome to our comprehensive tutorial on building a 3D real-time strategy (RTS) game. In this series, we will cover everything from setting up your environment to implementing core gameplay mechanics. Let's get started. Step 1. Setting up your development environment. Before we dive into coding, we need to set up our development environment. We will use the Unity game engine for this project. Download and install the latest version of Unity from their official website. After installing Unity, launch it and create a new 3D project. Name your project 3D RTS Game and choose a suitable location on your file system. In Unity, the first thing you'll see is the scene view, where you can build and arrange your game world. Familiarize yourself with the various panels, such as the hierarchy, inspector, and project panels. Step 2. Creating the game world. Let's create a simple terrain for our game. In the Game Object menu, select 3D Object, Terrain. This creates a terrain object in the scene. Select the terrain in the hierarchy panel and go to the inspector panel. Here, you can modify the terrain settings such as size and resolution. Set the terrain width and length to 500 units each. Adjust the height map resolution to 512 by 512. Next, let's add some hills and valleys to our terrain. In the inspector panel, under the terrain component, select the Paint Terrain tool. Choose the Raise or Lower Terrain tool and click and drag on the terrain to create hills. Step 3. Adding player units. Now that we have our terrain, it's time to create a player unit. In the project panel, right-click and create a new folder named Prefabs. Then right-click again and create a new 3D object, Capsule. This will be our player unit. With the capsule selected, rename it to Player Unit and reset its transform to position 0, 0.5, 0 to sit above the terrain. Next, create a new material for our unit by right-clicking in the project panel, selecting Create Material and giving it a bright color. Apply this material to the player unit by dragging it onto the capsule in the scene view. This will give our player unit a distinctive appearance. Step 4. Writing the player movement script. Now, let's make our player unit move. Create a new C# script by right-clicking in the project panel, create C# script, and name it Player Movement. Attach this script to the player unit by dragging it onto the capsule. Open the player movement script in your code editor. Here's a simple movement implementation using the keyboard input. This script allows the player unit to move forward, backward, left, and right using the WASD keys. Save the script and return to Unity. Step 5. Creating enemy units. Similar to the player unit, we need to create enemy units for our game. In the Prefabs folder, create another capsule and rename it to Enemy Unit. Change its color so it's easily distinguishable. After modifying the appearance, let's create a script for enemy behavior. Right-click in the project panel, create a new C# script, and name it Enemy Behavior. Attach this script to the Enemy Unit prefab. In the Enemy Behavior script, we will implement simple AI that will move towards the player's unit. Here's a basic implementation. This code uses the target's position to calculate the direction the enemy unit should move towards. You will need to set the target to reference the player unit. Step 6. Spawning enemies. We'll create a script to spawn enemy units at regular intervals. Create another script called Enemy Spawner and attach it to an empty game object in the hierarchy named Enemy Spawner. In the Enemy Spawner script, we'll implement a method to spawn enemies randomly on the terrain. Here's a sample code for that. This code makes the spawner call the spawn enemy method every 3 seconds. Adjust the spawn interval as necessary. Step 7. Adding game logic. To manage the game logic, create a game manager script. This script will handle interactions between player and enemies, scoring, and game states. In the game manager script, you'll need to manage the countdown of enemy units and handle unit deaths or crashes. First, let's start out with a basic setup. You can use the instance variable to access game manager functionalities globally. Next, implement a method to end the game when the player is defeated. Step 8. User Interface, UI. To display game data, we'll create a user interface. Under the Game Object menu, select UI Canvas. Inside this canvas, you can add UI elements such as text and buttons. Create a text element to show the player's score and set its properties as needed to ensure it is visible during gameplay. For this, create another script named UI Manager to manage UI elements. This UI Manager script will update the displayed score in your game. You can increase the score through events such as defeating an enemy. Step 9. Finalizing gameplay mechanics. With the main components in place, let's connect everything. Make sure each enemy detects and interacts with the player unit correctly, and adjust their behavior based on proximity. You can modify the enemy behavior script to include damage logic or any other mechanics that make interaction meaningful. This could involve reducing the player's health if an enemy reaches them. Step 10. Polishing and playtesting. Now that we've built the core mechanics, it's important to test your game. Playtest different scenarios to ensure that the game behaves as expected. Adjust parameters like movement speed and spawn rates until you are happy with the gameplay. Consider adding sound effects, animations, and other visual elements to enhance the overall experience. Unity Asset Store has many free and paid resources to help you. Step 11. Building your game. Lastly, once everything runs smoothly, prepare to build your game. Go to File, Build Settings. Here you can select your platform and configure your game build. Set up the build path, choose the appropriate settings, and click Build to package your game. Congratulations, you've created a basic 3D RTS game. Outro. Thank you for watching this tutorial. I hope you enjoyed learning how to create a real-time strategy game in 3D. Remember, game development is an iterative process. Don't hesitate to tweak and expand upon what we've created together. If you have any questions, leave a comment below. Be sure to hit the like button if you found this video helpful, and subscribe for more tutorials on game development and programming. Happy coding!